All right, who's ready to talk about money? Money, 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 money. So, say you're given $1,000 at your graduation party and you want to invest it for college because you know you're a responsible young adult. And the bank is like, hey, we'll offer you a CD, not like a compact disc. It's like an investment thing, right? Like a savings bond kind of deal. And it's going to give you 4.25% interest if you invest the money for 4 years. So right now, you know this is a hoax because they would never give you that kind of interest rate these days. But say they did. Tell everybody, all right? And let's calculate how much money you're going to have after 4 years. Well, in order to do that, you're going to need this awesome, super cool compound interest formula. All right? Now, this is very similar to what we had before with the growth and decay, except for a couple things. First off, that lowercase a is now a p. That's our principal. All right? Just your starting amount, just like before. The n is different. That is the number of times that the interest is being compounded. Before it was just annually, once a year. Now it might be, quarterly, daily, monthly, you name it. There's a lot of different ones, and we're going to get into those in just a sec. Did I say just a sec? Because I meant just a sec. Look at that. There they are. Annually, n would be equal to 1. Semi-annually, n would be equal to dos. That's 2. Quarterly, 4. Monthly, 12. Daily, 365, unless it's a leap year. Don't worry, we're not going to actually get you on that. We're not going to say make you calculate with leap year. So you're good. Daily's 365. So let's take two different scenarios here. It says, which plan yields the most interest? Plan A is a dollar investment with 7.5% annual rate compounded monthly, so compounded 12 times for 4 years, right? 12 times a year for 4 years. Plan B is a 7.2%, so a little less interest, but it's compounded daily, so it's compounded more times every year for the 4 years. Well, let's see what happens. Well, if we plug it into our new awesome formula, which would look like this, where you've got 1 for your starting amount, and then it's 1 plus your rate over the number of times it's compounded, raised to the number of times it's compounded times the number of years. And what you're going to end up getting is about $1.35, okay? Rounded, of course. Now our next plan, basically everything's going to be the same except for a couple parts. So what we end up doing is now it's 0.072 for our rate, and it's 365 for the n, the number of times it's compounded. So what we end up with is $1.34. Now, although our interest rate was 0.3% less, we still ended up very close to the same. And that is due to the number of times that it has been compounded. So it's been compounded more, so even though it's a little less interest, it still stays pretty close. And over time, they are going to change. And you can really start plugging in numbers for the amount of time and see what happens with the numbers. So why don't we head back to that college CD problem where you're investing $1,000 into a CD and you want to see how much money you're going to have after 4 years when it's being compounded monthly. And in this case, also, we're going to calculate when it's compounded daily. Same interest rate, same amount of time. Let's see how much money we have. Okay, so if I'm going to write out this formula here, it's going to be, well, I start with $1,000, so A of 4, because after 4 years, the amount of money after 4 years, $1,000 times 1 plus 0.0425 over, well, how many times is it getting compounded? 12. Okay, and then we're going to raise that. We're going to raise that up to the n times t, meaning 12 times the amount of time, which is 4 years. Okay, and if we plug that into our calculator, what I end up getting is about $1,184.95. Okay, now let's try it with the compounded daily. Starts out the same. I'm going to have 1 plus 0.0425 over 365, because that's how many times it's being compounded, raised to the nt, 365, times 4 years. And I probably should have made this a little bit more of like a smaller fraction like I did here. So, just be neat when you're writing it. So if I plug that in my calculator, I end up getting $1,185.29. So I end up with a little bit more. So when it's compounded daily, your interest is making interest on it as you compound it more times. So you're going to end up with a little bit more money later on down the road. Not much, but over time and with larger interest or larger amounts of money, it's going to grow faster.